We've reached the point in this lesson where you should now understand that the importance of exercise in weight loss efforts is not in that it is the primary energy expender and contributor to an energy deficit, but rather it is in the long-term physiological adaptations to exercise that help improve long-term weight control and elicits anti-obesogenic effects. Now, long-term adaptations include epigenetic modifications starting in the muscle to improve fuel utilization, especially fat, increase fuel uptake like fatty acids and glucose, increase mitochondria, which is where fuel is oxidized and energy is released, and decrease inflammation. Now, exercise also facilitates positive metabolic changes in other cells, like in the liver as well as adipose, through myokines, which are released by contracting muscles. These changes are all conducive to long-term weight control and overall metabolic health. Finally, white adipose, which is where fat is largely stored and where mass can accumulate, can undergo positive changes with long-term exercise that make it less conducive to energy/fuel storage and more favorable towards energy expenditure. This process is mediated also through communication from exercising muscles via myokines, as well as norepinephrine, all of which are stimulatory to mitochondrial biogenesis in white adipose cells. In so doing, white adipose cells become browner or more beige through a process referred to as beiging. Again, the change in color is due to having more mitochondria, which are darker, and less fat stores or droplets, which are lighter. So if I ask a question such as, which of the following contributes to the change in color during the beiging process in white adipose cells? The answer would be increased mitochondria and less lipid/fat stores. Also remember, another term to describe an increase in mitochondria would be mitochondrial biogenesis. So the next question would be, well, what mode of exercise is ideal for these long-term adaptations that we discussed previously? What does the research in general tell us about this question? The answer is simple. These adaptations that we discussed that are favorable for long-term weight control are not specific to any one mode of exercise, meaning these adaptations don't just occur in response to, say, endurance training or quote-unquote cardio. These adaptations will occur in response to any mode of exercise, whether it's endurance training, resistance training, CrossFit, swimming, running, etc. You must remember the fundamentals of training adaptations, like those adaptations we just discussed. What are you adapting to when you train? You are adapting to a stressor, meaning adaptations take place when your body is under some type of stress for a period of time, something your body is not accustomed to, in other words. Exercise is a stressor to the body, so when applied over time consistently, your body will adapt to this stressor so it is no longer quote-unquote stressful. Through the process of adaptation, your body will experience positive changes that is usually conducive to better health, a stronger body, if you will. So the key is stress. If there is no stressor, there is no reason for adaptations to take place. So in practical terms, your exercise training program, no matter what mode you are using, needs to induce stress. It needs to be something your body is not accustomed to. This means you can't just do the same things over and over again and expect to see positive changes continually occurring. We see people do this all the time. They walk the same pace, same distance every single day, and in the beginning, yes, some adaptations and positive changes took place, but what happens over time? Stagnation, plateau. No more adaptations or changes. Why? Because your body has already adapted sufficiently to the exercise. It is no longer a stressor. So the key to progressively achieving these positive adaptations is to implement progression in your training program. Again, you have to progressively modify your training as you adapt to it to continually experience positive adaptations. So as long as your training program has that as its foundation, you will then experience the adaptations and thus benefits that we discussed earlier. If you just want to simplify this completely, what all this is saying is basically work hard when you exercise. Now, with this being said, we now know that we can reap the long-term benefits of exercise for weight control by any mode of exercise as long as we work hard, maintain consistency, and progressively modify the training to apply sufficient stress. So in summary, Exercise during weight loss efforts should not be viewed as a means to create a significant energy deficit. Exercise is a long-term focus and should be performed for improved long-term weight control through positive metabolic adaptations in the body. So the next question is, what should be the immediate focus of exercise programs during weight loss efforts if it is not just energy expenditure? The immediate focus of exercise programming during weight loss efforts should be on maximizing weight loss quality, which is a newer concept presented in the scientific literature that has shown to be more critical than just simply weight loss quantity, which is what most people focus on. So what is weight loss quality? Weight loss quality is a concept of maximizing the reduction of adipose mass, or fat loss in general, while preserving or improving lean mass, particularly skeletal muscle, during a caloric deficit. So as you can tell, weight loss quality is not just about the quantity of weight loss, but optimizing the changes in body composition. We know by now that the caloric deficit will drive overall weight loss, especially in adipose. But can we utilize exercise and perhaps some nutritional strategies during a caloric deficit to optimize body composition and thus improve weight loss quality by preserving or improving muscle mass? The traditional thought is no, you cannot maintain muscle mass during an energy deficit due to the increased reliance on endogenous fuel sources like fat, carbohydrate, and amino acids, such as those found in muscle proteins, to overall meet the total energy needs of the body. Now, because proteins make up a large portion of the mass of muscle, it is thought that since an energy deficit would increase the breakdown of those muscle proteins into amino acids because the body needs to utilize those amino acids for fuel, it would be impossible to preserve or increase muscle mass during an energy deficit. So does this mean the traditional strategies to improve muscle mass, such as resistance training and increased dietary protein intake, can't improve muscle mass during a caloric deficit? Well, let's dive into the scientific research to answer this question. Here we have the results of a study that was published in 2016 in the American Journal of Clinical Nutrition. Now, this was one of the pioneer studies that introduced the concept of weight loss quality, and multiple studies thereafter have further investigated the same research inquiry. So the purpose of the study was to examine the effects of protein intake on body composition during a period of caloric deficit. So in this study, researchers compared high versus moderate daily protein intake. So one group consumed a caloric restriction diet that had a daily protein intake of 1.2 grams per kilogram of body weight per day, while the other group consumed a caloric restriction diet that had a daily protein intake of 2.4 grams of protein per kilogram of body weight per day. Now keep in mind that the level of caloric restriction was controlled for between these two groups. So the only factor different between groups was the daily protein intake, high versus moderate. Also, each group underwent the same exercise training program that consisted of resistance training and high-intensity interval training, which was performed 6 days per week for 4 weeks. Now, the time span of the experiment was 4 weeks, and body composition was measured before and after the 4 weeks. And finally, the change in body mass, lean mass, and fat mass was compared between the two groups. So now let's take a look at the results. First, body mass changes. From a statistical analysis standpoint, there was no significant difference between groups in the change in body mass. In other words, both groups experienced a similar reduction in body mass across the 4 weeks. Again, this was driven by the caloric or energy deficit, which was mainly due to the caloric restriction. Now let's take a look at the composition of this body mass reduction. First, lean mass, which is largely attributable to muscle mass. The results showed that the group that consumed the higher daily protein intake of 2.4 grams of protein per kilogram of body weight per day had a significantly greater increase in lean mass than the group that consumed the lower daily protein intake. So just from these results here, you can conclude that 1, resistance training can improve lean mass while restricting caloric intake, and 2, higher protein intake during caloric restriction and resistance training can enhance the improvement of lean mass. And this is just across 4 weeks. Now, what about fat mass, which is largely comprised of fat stored in adipose? Now, as you can see, both groups, because of the caloric restriction and thus caloric deficit, had a significant decrease in fat mass across the 4-week intervention. But interestingly, the group who had a greater daily protein intake lost significantly more fat mass than the group who had a lower daily protein intake. So when looking at this data overall, which group would you say had a superior weight loss? Well, neither. Both groups lost the same amount of body weight. But then which group would you say had superior weight loss quality? The group with the greater daily protein intake had superior weight loss quality. Although both groups lost the same amount of weight, the group who consumed the higher daily protein intake of 2.4 grams of protein per kilogram body weight per day was able to improve lean mass through resistance training and reduce fat mass to a greater extent than the group who consumed a lower daily protein intake. So yes, this study, along with others, show that during a caloric restriction and thus caloric deficit, you can improve lean mass with higher protein intake, at least around 1.2 to 2.4 grams per kilogram body weight per day. And this is obviously in conjunction with resistance training. Now, in this study, 2.4 grams showed to be superior to 1.2 grams, but anything above the RDA of 0.8 would yield better results for lean mass during a caloric deficit in conjunction with resistance training. Now, another key takeaway to consider is that the greater the caloric deficit, the greater importance of higher protein intake. So some studies had even looked at 2.8 grams all the way up to 3 to 3.2 grams. Now, what's also interesting about these findings is that a caloric restriction diet of higher daily protein yields greater fat loss. Does this mean protein has some kind of fat burning effect? Absolutely not. That is not the case. So what could possibly explain why a higher protein caloric restriction diet yields greater fat loss? Well, first, let's discuss the differences between the two caloric restriction diets represented in the study. First, as we said, the degree of restriction and thus the caloric intake was the same between groups. So if the protein intake is higher in this group, then the lower protein intake group has to somehow make up for those protein calories. This is done through higher carbohydrate intake in the lower protein group. So in summary, this group had lower carbohydrate and higher protein intake than this group. Okay, so now that we have that covered, let's explain why the higher protein and lower carb group had significantly greater fat loss than the group that had lower protein and higher carb intake, despite the degree of caloric restriction being the same between those two groups. Here's where you need to take some careful notes. So as most of you know, protein is made up of amino acids, and the sequence of those amino acids determines the type of protein. Now, among amino acids, there are 9 essential and 11 non-essential amino acids. Essential amino acids are the ones that your body cannot produce, and non-essential are the ones your body can produce. The body utilizes all these amino acids to construct proteins with, such as the individual proteins found inside, say, muscle cells. These amino acids are referred to as proteogenic, meaning they serve as building blocks for proteins in the body. Now, there are also 2 other functions of amino acids in the body. Not only are they used to build proteins with, some are used to form glucose, which is a simple carbohydrate molecule. This group of amino acids are called glucogenic amino acids, and 18 of these amino acids are glucogenic. The other function of amino acids is for energy, meaning these amino acids can be oxidized and used to provide energy to the cells. These amino acids are called ketogenic amino acids. There are 2 amino acids that are just ketogenic and 5 amino acids that are both glucogenic and ketogenic. Okay, so now there are some important questions to answer. First, can amino acids be converted to fat molecules? The answer to that is technically yes, but the pathway to get there is very, very inefficient. The only amino acids that can eventually be converted to fat are the glucogenic amino acids. But in order for this to happen, the glucogenic amino acids must be first converted to glucose in the liver through a process called gluconeogenesis, formation of new glucose. Then the glucose has one of 3 fates. It can be stored somewhere as glycogen, It can be oxidized for energy through a process called glycolysis, or it can be converted to fatty acids. So as you can see, the pathway from an amino acid all the way to fatty acid synthesis is quite a long way. So this is not a favored pathway in human metabolism. Now let's put this in the context of an energy deficit. Remember, during an energy deficit, more endogenous fuel, so fuel stored in the body, is being utilized and oxidized to meet the body's energy needs. So if there is an increase in amino acid availability because you are consuming more dietary proteins, do you think those amino acids will be used to form fatty acids? No. The ketogenic amino acids will be oxidized directly for energy support to help meet the energy needs, and the glucogenic amino acids will likely be converted to glucose, and the glucose would thereafter be oxidized to help meet the energy needs of the body. Now, when you add resistance training to the mix, this stimulates protein synthesis within muscle, which is where most of the proteins in the body can be found. So much of the amino acids that are available from your added protein intake through your diet will be used to build more muscle proteins. So as you can see, a caloric deficit combined with resistance training is not a favorable condition for glucogenic amino acids to be converted to fatty acids. Even without these conditions of a caloric deficit, the conversion of amino acids to fatty acids is not favored. So in the lower protein intake group, like I said, they had higher carbohydrate intake than the higher protein intake group. This would provide more glucose to the body, which has an easier quote unquote pathway to be converted to fatty acids and stored compared to amino acids. So in summary, additional dietary protein provides additional amino acids which have a lower chance of becoming fat molecules and being stored as fat molecules compared to a caloric restriction diet with higher carbs and less protein. Either way, however, as long as you have a caloric restriction, you will experience fat loss because that would create a caloric deficit. The question is, can you optimize weight loss to be more quality? The evidence shows that it is possible with higher protein intake with resistance training. Now, here is some further evidence of the benefits of resistance training and higher protein intake during a caloric deficit on weight loss quality. Now, this study included subjects that were aspiring female physique competitors. Just like the other study, the subjects were split into two groups. One group consumed 2.5 grams of protein per kilogram body weight per day, while the other group consumed 0.9, which is close to the RDA. Now, both groups consumed their respective dietary treatment and also performed resistance training for 8 weeks. Body composition was measured before and after the 8-week treatment period. Now, as you can see in this figure here, the results of this study were similar to that of the study presented in the previous slide. The higher protein intake group had a significantly greater decrease in fat mass and a significantly greater increase in lean mass, or in this case, fat-free mass, compared to the lower protein intake group. So this is just another piece of evidence suggesting the importance of higher protein intake and resistance training to improve weight loss quality. Again, that's maximizing fat loss while preserving or improving lean mass. Now here I present a study that I conducted and recently published in the Journal of Clinical Nutrition in 2017. If you are interested in reading this study, please ask and I will link you to the paper. Now, the objective of my study was to see whether progressive resistance training can improve lean mass and therefore weight loss quality under severe caloric restriction and therefore severe caloric deficit. Now, in order for me to study the effects of resistance training in a severe caloric restrictive condition, I needed to use severely obese individuals who again have a very high weight stable caloric intake. If I use leaner individuals, there's not a lot of room for caloric restrictions since their weight stable caloric intake is not as high as someone who is severely obese. So I had subjects in the study consume only 950 calories per day for 12 weeks straight through a medically supervised weight loss diet formula. Now, based on baseline measurements of their weight stable caloric intake, this equated to a caloric restriction of about 2,500 to 3,000 calories per day, meaning their weight stable caloric intake was anywhere from 4,000 to 5,000 calories per day, so a lot of calories each day. So we split the subjects into two groups. One group performed progressive resistance training, while the other group, which was the control group, performed exercise based on current clinical recommendations for obese individuals, which was basically light aerobic exercise. Nothing too complex. So body composition, resting energy expenditure, muscle function, and a bunch of other measures related to fat metabolism, inflammation, and muscle metabolism were taken before, mid, and post intervention. So at 0 weeks, at 6 weeks, and at 12 weeks. Now let's take a look at the results. For total body mass, as you would expect with such severe caloric restriction and therefore deficit, subjects had a significant reduction in body mass. The resistance training group lost 35 pounds across 12 weeks, while the control group lost 43 pounds across 12 weeks. Now, as a side note, you can see that at mid-intervention, the rate of weight loss for either group slowed down. Why? Because of adaptive thermogenesis. What is happening? The subject's BMR, or resting energy expenditure, is decreasing to adapt to the lower caloric intake, and therefore, even though they are still consuming only 950 calories per day, the deficit is shrinking due to adaptations. Anyways, going back to the body mass reductions here. Based on just this data here, some would say that the dietary treatment was more effective in the group that did not perform resistance training, the control group, since they lost on average 8 more pounds than the group that performed resistance training. But as we all know by now, body mass does not tell the whole story. Let's look at the quality of this weight loss here, looking at body composition changes. Here on top, we see changes in lean mass, and on the bottom, changes in fat mass. What do we see? As you can tell, fat mass decreased equally between both groups, and the majority of the weight loss was attributable to fat loss, which is expected. But what about lean mass? As you can see in the resistance training group, lean mass was completely preserved across the entire 12 weeks despite being under a severe caloric deficit. Again, the deficit was about 2,500 to 3,000 calories per day. In the control group, who again did not do resistance training, they lost about 10 pounds of lean mass, which is what one would expect if you were under such a severe caloric deficit. If you ask any average person, they would say retaining muscle mass under such a severe caloric deficit would be impossible. Well, my research data shows otherwise. Progressive resistance training can be an effective means to improve weight loss quality by preserving or improving lean mass even during severe caloric restrictive diets. So yes, resistance training is a very important aspect of weight loss treatments for obesity. Now, what is cool about this study is that this was a clinical trial in collaboration with the bariatric department of a large hospital. And because of the data obtained from this study, this bariatric unit of this hospital is now implementing resistance training as a key component of their patients' treatment programs. So fitness professionals are being hired by these hospitals to treat their obese patients. Now, some data that is not shown here are results from muscle function tests. In the control group, maximum muscle force production decreased, along with the decrease in muscle mass. But the resistance training group not only preserved muscle mass, but their strength increased dramatically. So overall, the quality of weight loss was positive with resistance training, not only from a body composition perspective, but also a physical function perspective, as well, of course, from an overall health perspective. Okay, so if we looked at the composition of the weight loss in each group, we can see that without resistance training, approximately 76% of the weight loss was due to fat loss and 24% was due to a loss of lean mass. Now, this is a typical composition of weight loss, about a quarter due to lean mass loss and 3/4 due to fat loss. Now, as you can see in this figure to the right, the composition of weight loss was drastically improved by resistance training. 96% of the weight loss was due to fat loss, and only 4% was due to lean mass loss, although statistically there was no average loss of lean mass in this group right here. So what is the significance of these results? Well, as I said before, resistance training and the prevention of lean mass was associated with improvements in muscle function, which is a very important determinant of health, especially those who were obese and had multiple comorbidities and was likely sedentary. But what else? Let's take a look at the changes in BMR, or resting energy expenditure. As we emphasized in the last lecture series, as adaptation to a prolonged caloric deficit, the BMR will decrease, and that is what we see here. Both groups experienced a decrease in BMR. But in the group that performed resistance training, BMR decreased at a slower rate, and this was associated with the preservation of lean mass. So not only did the resistance training group lose the same amount of fat mass as the control group and preserved lean mass, they have a higher BMR than the control group after 12 weeks. This means they have a greater propensity to continue losing weight, and a situation that makes it easier for them to maintain a caloric deficit for continual weight loss. So the takeaway here is that no matter how severe the caloric deficit, resistance training will be effective in improving weight loss quality. Okay, so far with the research we've discussed thus far, weight loss quality is improved with resistance training and higher protein intake. So now the question is why? Why does resistance training and higher protein intake improve weight loss quality? How does it counteract the negative effects of a caloric deficit on muscle mass, as we saw in the control group of this study who lost 10 pounds of lean mass across 12 weeks? Now let's dive into the physiology. Okay, first, why is an energy deficit conducive to a loss of muscle mass? Now first you must understand, just like how the mass of adipose is largely attributable to the mass of fat molecules in the adipose cell, the mass of muscle is largely attributable to the mass of proteins in the muscle cells. The muscle cell is made up of primarily water and protein with a little carbohydrate and fat stores. Now, during an energy deficit, we know that there is an increased reliance on endogenous or stored fuels such as fat, carbohydrate, and protein, or more specifically, its building blocks, amino acids. This means there is increased catabolism or degradation of muscle proteins to free up amino acids. Protein breakdown is referred to as proteolysis. So during an energy deficit, there is increased proteolysis of muscle proteins. So as I said, this would free up more amino acids to be used for two main purposes during an energy deficit. One, amino acids can undergo oxidation to provide energy to cells, and the mass of the amino acids, which is made up of carbons, hydrogens, oxygens, and nitrogens, are excreted from the body. The carbons and oxygens are again expelled in the form of CO2. The hydrogens and oxygens are expelled in the form of excretory fluids, water, and nitrogen is excreted in urine. Now second, some amino acids, the glucogenic amino acids, can be used to form glucose primarily in the liver. This is again referred to as gluconeogenesis. Now during an energy deficit, the free amino acids do not favor this path right here. This path is protein synthesis, meaning it's not a condition in which free amino acids can be used to construct new proteins like muscle proteins. Now, one of the major reasons why is that protein synthesis or anabolism is energy costly. So during a state of energy deficit, this would not be ideal. Now, this doesn't mean that protein synthesis does not occur during an energy deficit. It just means that the rate of protein degradation exceeds the rate of protein synthesis, particularly in muscle. So the net effect over time during a caloric deficit will be a loss of muscle mass, since again, the mass of muscle is largely attributable to its protein content. So how can this effect on muscle be counteracted? Well, we discussed evidence showing that higher dietary protein intake and resistance training can preserve or even improve lean mass during a caloric deficit state. So how do these interventions counteract the effects we see here? Now in this figure, the arrows that are red indicates the effects of the caloric deficit, and this was shown in the previous slide. The arrows in blue indicate the effects of higher dietary protein intake and resistance training. So first, how does higher dietary protein intake counteract the negative effects of energy deficit on muscle mass? Well, the major contribution of dietary protein is to the free amino acid pool. Remember, when you consume protein, the digestive system degrades it into building blocks, the amino acids. They are subsequently absorbed and enters blood circulation, and they are circulated to different cells in the body. Well, because exogenous sources of amino acids are contributing to this free amino acid pool, there is less reliance on endogenous amino acids within endogenous proteins like those in muscle. This means there are more amino acids available to be used to synthesize new muscle proteins. Now, all that is needed is a stimulus for muscle protein synthesis. And what do you think the most potent stimulus for muscle protein synthesis is? It's the mechanical stress or tension from resistance training. Resistance training will stimulate muscle protein synthesis or anabolism, since this is an adaptive response to the stress of lifting weights. So you have a greater pool of free amino acids from higher dietary protein intake, and you have a stimulus for muscle protein synthesis in the form of resistance training. Also, as a side note, leucine is an essential amino acid that has shown to be stimulatory to muscle protein synthesis as well. So dietary protein sources rich in leucine would also be ideal. So this is related to the quality of the dietary protein. You not only want a full complement of essential amino acids, but also a good source of leucine. In terms of supplementation, most protein supplements are high quality, especially whey protein, since it provides all non-essential and essential amino acids, which include leucine, at about 3.5 grams per serving. Eggs and most meats are also good sources of essential amino acids, which again include leucine. Alright, so as far as weight loss quality is concerned, resistance training and higher protein intake are beneficial. But what are some other benefits of exercise and dietary protein during weight loss endeavors? Now, as we know, a caloric restrictive diet is only as good as the adherence to it, right? It doesn't matter what type of diet you are consuming to lose weight if you don't adhere to it. So one of the major factors affecting adherence to a caloric restrictive diet is obviously hunger. And we discussed earlier that hunger is not just psychological, but it is physiological as well. It is a result of signals mainly mediated through hormones and neurotransmitters, communication molecules. So remember, we discussed anorecogenic and orexigenic hormones. Anorecogenic hormones suppress hunger and orexigenic hormones stimulate hunger. During a caloric deficit, the immediate response to reestablish energy homeostasis is hunger, to encourage eating. This is again an orexigenic response. And this is one factor that causes failure to adhere to a caloric restriction diet. The body initially is fighting against this caloric restriction. So what if there was a strategy to inhibit this orexigenic response and support anorecogenic responses or hunger suppression during a caloric restrictive diet? This would likely improve adherence. Well, let's take a look at this 2015 study. Now, this study compared 12 weeks of high-intensity training versus low-intensity training on ad libitum daily caloric intake. Ad libitum just means voluntary and unrestricted, meaning subjects ate under their own volition. Now, before and after the 12-week intervention, researchers measured how many calories subjects consumed per day. Before the training intervention began, subjects consumed about 2,300 calories per day in each group. After the 12 weeks of training, ad libitum caloric intake was measured again. Now, in the group that performed high-intensity training, there was a significant decrease in ad libitum daily caloric intake from 2,300 calories to 1,700 calories per day. In the low-intensity group, however, the daily caloric intake did not change from pre to post training. So something about high intensity training caused subjects to consume less calories after 12 weeks of training. So what can explain these outcomes? Now, in this study, the researchers took blood samples from each subject to examine levels of a gut hormone PYY or peptide YY. We discussed in our last lecture series that PYY is an anorecogenic hormone, meaning it suppresses hunger. It inhibits NPY, which is a orexigenic neurotransmitter. This is a hunger stimulator. So if PYY levels increase, there will be a decrease in hunger through the inhibition of NPY. What they found was that subjects who performed high-intensity training had a 22% increase in PYY levels compared to the low-intensity training group. This increase in PYY levels was correlated to decreased feeling of hunger, which could explain the decrease in ad libitum caloric intake from pre to post training. So it appears that high intensity is more advantageous for hunger suppression over time compared to low intensity training, which could improve overall adherence if one was under a caloric restrictive diet. Now, as practical application is concerned, we know that during the initial period of a caloric deficit, NPY levels and thus appetite are increased. This is again an anorexigenic effect and is one of the major factors contributing to poor adherence. Well, with high intensity training, such as high intensity steady state training or high intensity interval training during or even prior leading up to a caloric restriction diet, this might aid in inhibiting appetite and suppressing hunger through increases in PYY and therefore decrease in the effects of NPY. Okay, so as far as exercise training programs are concerned, resistance training for improved weight loss quality, high intensity exercise, which can be in the form of resistance training for improved adherence through appetite suppression, and of course, all those long-term adaptations and benefits of exercise on overall metabolic health can be achieved through any mode of exercise. Now, in addition to resistance training and high intensity training, we also indicated that higher dietary protein can be beneficial to weight loss quality by supporting the preservation or improvement in lean mass as well as facilitation of fat loss during a caloric deficit. Now, going along the theme of adherence, in this study, researchers compared hunger levels and PYY levels after a single meal. One meal consisted of primarily protein, one meal primarily carbs, and one meal primarily fat. They measured hunger levels up to 180 minutes post-meal, and what they found was that the protein-heavy meal elicited lower levels of hunger post-meal compared to the fat and carb-heavy meals, meaning it was most satiating compared to the carb and fat-heavy meals. This was also explained by anorecigenic responses due to elevated PYY levels. PYY levels normally rise after a meal to signal satiation, but as you can see in this figure, PYY levels were elevated following the protein meal compared to the carb and fat meal. So this is more evidence on the importance of higher protein intake during a caloric restrictive diet, even beyond weight loss quality. Okay, so to conclude this lecture series, let's go over some take-home messages. 1. Caloric/energy deficit is the primary and possibly the only driver of weight loss. That is, less mass coming in than mass going out. 2. Caloric/energy deficit is most effectively achieved via caloric restriction since it is difficult to create a significant caloric deficit via increasing exercise energy expenditure or TEA. 3. When the caloric/energy deficit is sustained, adaptive thermogenesis will suppress basal metabolic rate or resting energy expenditure to reestablish energy homeostasis. This will minimize the deficit, resulting in a weight plateau. Remember, no caloric deficit equals no weight loss. 4. Exercise programming during caloric deficit should be predicated on weight loss quality and optimizing body composition changes, not just simply to burn calories. Now, here are some more take-home points, specifically on nutrition, some key points here. First, utilize at least a 2-week log of daily dietary/caloric intake using dietary tracker applications such as MyFitnessPal, as well as body weight using the same scale. This is before the first meal and after first void. Now, this is to establish your weight-stable total daily caloric needs and a reference for subsequent caloric restriction. This is again to figure out what your weight-stable caloric intake is. From there, create a caloric deficit via caloric restriction based on current total daily caloric needs. You can go aggressive or conservative. You will eventually plateau, again, because of adaptive thermogenesis. Now, we talked a lot about how important increasing your protein intake would be to maximize weight loss quality especially. The current evidence-based recommendations for daily protein intake during a caloric deficit would be 1.2 to 2.4 grams of protein per kilogram of initial body weight per day. Now keep in mind you have to readjust per gram intake when the weight plateaus. Now this protein intake per day is about 2 to 3 times the recommended daily allowance, the RDA. Next, carbohydrate and fat intake does not matter significantly, at least initially, for overweight and obese individuals. Carb and fat composition of your diet may be more relevant for small-scaled body compositions, quote-unquote, refinement. So for those who are already lean and need to lose a few pounds. Next, there is not one caloric restriction dietary program that is inherently superior than another. Okay, keep that in mind. So whether you're doing intermittent fasting, you're doing a ketogenic diet, you're doing a low-carb diet, you're doing a low-fat diet, whatever it may be, not any single one of those diets is inherently superior than the other. It's all about creating a caloric deficit via caloric restriction. All those diets that you've heard of in the past, they all technically work to induce weight loss because they all create a caloric deficit. You are restricting calories through those diets. There is no magic formula. If the diet, whether it is intermittent fasting, ketogenic diet, or liquid diets, if it involves a caloric deficit, then weight loss will occur. This is again based on physical law. So for example, for a given individual, if an intermittent fasting program provided a caloric restriction of 200 calories per day, it would likely produce the same rate of weight loss versus a continuous non-intermittent diet that also restricts calories by 200 calories per day. This is because, again, caloric deficit is the main driver of weight loss based on the fundamental science of body mass control. More fuel mass being exhausted from your body versus consumed and stored in your body. The diet that is superior, quote unquote, is on an individual basis and is characterized largely by adherence and long-term success. Meaning, a diet, no matter how much evidence is behind its efficacy, will not be effective if you cannot adhere to it. So pick a program that you can adhere to. If you have failure adhering to a program or the program is just simply too hard, then you got to look for a different one. Now, as far as some take-home points for exercise, first, do not buy into the quote-unquote fat burn zone training, often referred to as cardio. This ideology is just not evidence-based. Do not view exercise as the main route for creating a caloric deficit or a way to just target fat loss. The benefits of exercise and weight management is mostly in its long-term effects or adaptations that improve overall energy metabolism. Focus exercise programming on weight loss quality, preserving or increasing lean mass, and maximizing fat loss. And yes, you can gain muscle during caloric deficits, even severe caloric deficits as shown in my study. Now, one of the major points is that progressive overload resistance training is a must during caloric restrictive states. The research shows the benefits, including my research as presented in this lecture series. Don't fall into the trap of you having to do constant cardio to quote unquote maximize fat loss or burn fat. Focus on maximizing weight loss quality through progressive overload resistance training. Limit endurance training / conditioning frequency to moderate, about 2 times per week, so that you may promote energy expenditure without becoming overly energy efficient due to aerobic adaptations. So doing too much conditioning too early may not be the best for your caloric deficit as you become more energy efficient, which would not be conducive to maintaining a caloric deficit. This doesn't mean don't do high intensity exercise training. It just means to moderate it, at least in the beginning. Most of the work on weight loss will be afforded through your caloric restriction. Lastly, again, to reiterate, forget the quote-unquote fat burn zone. This is not evidence-based information.